Good morning, everyone. Am I audible? Yes or no? Am I audible or not?
Yes, ma'am.
Okay. So where are the other students? Only 11 students have joined. Ask them to quickly join, okay? I hope my screen is visible.
Ma'am.
Yes, it's visible, right? My screen.
Yes, ma'am.
Okay. Okay, then let us start. So, last class we have discussed about the characteristics of your raw water. Yes. So, after you know the characteristics, now we will be going to the treatment part. Okay, treatment of raw water. So, the raw water. Okay, that should be that should be treated. No, it should be treated and it should be made purified, so that like before you distribute it to the like any consumers, okay, for whether it may be for your domestic purpose or industrial purpose or for any other use, okay. So before you supply it to the general public, so the raw water which you have taken through the like the source, like river, lakes, okay, ponds, so all those water, the raw water, it has to be treated and it has to be made purified, okay. So like you have read about the characteristics for what, because to know how much extent of treatment is required for that raw water, okay. So you have to know how much of treatment, how what is the extent of treatment you have to give to that raw water, by knowing what, by knowing the characteristics, whether it is physical, whether it is chemical, or it is biological. So all those three characteristics, when you know, then after that you can go to the treatment part, okay. So now this treatment of water, it is, there are certain steps, okay. There are different methods by which you can this purify or you can treat the raw water. So first is your screening, okay. First is your screening, then comes your plain sedimentation, then comes your sedimentation aided with coagulation, then filtration, then disinfection, then aeration, then softening, and some other miscellaneous treatments are also there, like your fluoridation, recarbonation, liming, desalination, etc. Okay. So now These are the methods. Okay, so in short, if we would like to if so you have to explain to somebody, so what are these steps or what are these methods described. Okay, so what is your screening part? So like in the raw water, in the rivers, in the lakes, in the ponds, there are very like most, you can see some big and visible objects are there, plastics are there, trees are branches of trees are there, you can see some sticks, you can see some dead fish, animals, they are floating. Yes, so the screening, the work of the screens are to like to remove uh, this like floating objects, okay, whatever are floating there, so you have to remove that from the raw water of surface sources. Okay, and that work is done by your screening. Okay, so now after the big and visible objects, these trees and sticks and plastics and all these things are removed. So now, what about the coarser materials? Okay, so the coarser suspended materials, what they are done, because since they cannot be removed by screening, so these coarser suspended materials, they are allowed to settle down in a settling or in a sedimentation tank. Okay, so these coarser items, coarser materials are allowed to settle down in the sedimentation tank or sedimentation basins. Okay, and this whole process of settling down the water in a sedimentation basin is known as what? It is known as your plain sedimentation. In that way, you can remove the coarser suspended materials that are available in the raw water. So after that, the like this sedimentation process, it may be more effective, okay, if you mix some certain chemical compounds to the water. Okay, so the effectiveness of this sedimentation process, it will again increase if you mix some certain chemical compounds to the water. Okay, and when you mix these chemicals to the water, so what will happen? A precipitate or flocculate or a precipitate will form. Okay, which like with the particles which are not being able to settle down in the sedimentation basin. So if you mix some chemicals to the raw water, so they will agglomerate. Okay, so these particles and the chemical compounds, these will agglomerate with each other and they will finally settle down as a precipitate. Okay, so now this process, it is known as your chemical coagulants. Okay, and the chemicals are known as your coagulants. Okay, this chemical coagulants are, or the process is known as your chemical coagulation. So now the finer particles, okay, then after this settles down, then there are again much more finer particles that remain in suspension. Okay, so those finer particles that are in suspension, okay, that cannot be settled down in the sedimentation basin even after using your chemical coagulants, so it is removed by what process? Those finer particles that cannot be removed by your sedimentation process by using coagulants also, those are removed by your process known as your filtration. Through filters, you remove those fine particles. Okay, and the process is known as your filtration process. Okay, now after you do the filtration, that filtered water, okay, that may again and still it may contain some what? Bacteria, some pathogenic bacteria it may again contain. Okay, so those bacteria you have to remove because you have to remove that bacteria by what? By adding some chlorine. Okay, chlorine, and there are different these chemicals are there by which you can remove these pathogenic bacteria. And this process, like you when you kill the germs or the pathogenic bacteria from the raw water, so that process is known as your disinfection process. Okay, so now after you do the disinfection process, the water, okay, after the disinfection process, the water, it now becomes somewhat safe to drink. But Also, it will not be, you cannot drink that water because there will be some unpleasant odor. Okay, there will be some taste and odor, unpleasant taste and odor will be there, and you cannot drink that water for that. Okay, so again you have to remove that taste and odor. Okay, how will you remove the taste and odor? By again you use some chemical compounds such as what, such as activated carbons or ozone. Then uv rays are there. Okay, so some different methods are again there, and that process is known as your aeration process. That means you give some oxygen and you remove the unpleasant taste and odor. Okay, so now after you do the aeration process, the water, it becomes now hard. Okay, the water, it becomes hard due to the addition of some chemical compounds. Okay, so now you have to make the water to permissible. You have to remove the hard water and make it soft to some permissible limit. Okay, and then again you have to go to a process that is known as your softening process. Okay, the hard water, you have to make it soft up to a permissible limit, and that is known as your, the process is known as your softening process. Okay, so now the after you do the softening process, the water, the resulting water, it will be given a further treatment which is known as your fluoridation. Fluoridation is what, you have to add fluoride. Okay, the soluble fluoride you have to add for what, to such that people don't have dental caries. This the like that there is one what is called, yeah, dental caries. Okay, that is in teeth. Okay, so there's so that this dental caries doesn't happen. To control the dental caries, you have to add fluorine to the water. Okay, so to remove the fluoride. Okay, then again you can do the liming process. Okay, to remove to addition of lime, to control what, to control the corrosive action. Okay, then recarbonation is there. Recarbonation is due to the like addition of carbon dioxide, so that there is no deposition of calcium carbonate in the water. Okay, like this. Again, one more, desalination is there. Desalination is what, this is a removal of excess salt in the water. So all these techniques, it describes your the methods of your treatment process in a brief. Okay, so now we have to go through each and every steps, though it is familiar to you, but then also we have to go again, we have to revise it. Okay, so now comes the first process that is known as your screening. So what did I tell you? The screening. Screening is, like to remove the all the big things, like whether it is a plastic or it is a branches of trees or sticks or dead animals or vegetations, all those things which are in the like the large size particles. Okay, so you can say the large size particles, you have to remove it with the help of a screen. So where the screens are provided, these screens are provided in front of the pump. Okay, or the intake works, like from where you are taking the water. Okay, you are taking the water with the help of an intake. So in front of the intake or in front of the pump, you will be providing your screens, so that the large size particles, they gets excluded in the first stage only. Okay, so you will put the screen in front of the pumps or the intake valves, so that you can remove these large size particles. Okay, so there are, again you can say, there are two types of screens. Okay, number one is your coarse screen and the number two is your fine screens. Okay, so these coarse screens, okay, they are sometimes, okay, they are placed in front of the fine screens. These coarse screens are sometimes, these are placed in front of the fine screens. Okay, and now this coarse screens and the fine screens, what is the difference between them? The difference is about the like the this spacings. Okay, the spacings is the difference. So these core screens, what they contain, they consist of some parallel iron rods. Okay, they consist of parallel iron rods which are placed vertically at a certain slope. Okay, they are placed vertically at a certain slope, and what is the distance? The distance is about 2.5 to 5 centimeter apart. Okay, and these fine screens, they are made up of, like wire mesh. Okay, they are made up of some wire mesh openings. Okay, they have openings, but the openings, it cannot be more than your 6 millimeter square. Okay, and these core screens, they first remove the, like the floating bodies, the large sized particles, they first remove, and the organic solids also they remove, and then the fine screens, what they remove the fine suspended solids. Okay, they remove the fine suspended solids, and the core screens, they remove the large size particles or the bigger floating bodies. Okay, and the organic solids also. So now this core screens, okay, they are just now I told you that they are kept at a certain slope. Okay, so what is the slope? They are inclined at about your 45 to 60 degree Celsius. Okay, 62 or 45 to 60 degrees Celsius to the horizontal. Okay, why this is kept at 45 to 60 degree? Why it is kept at a like inclined position? So that it increases the opening area. Okay, so that it increases the area, and if the area is increased, the velocity, the flow velocity, it will decrease. Okay, and then if the flow velocity decreases, what will happen? It will make the screen more effective, and it can like exclude more no, more amount of these large size particles. Okay, so again, nowadays what happens is that these fine screens, they are not normally used. Because why? Because these fine screens, they always get clogs very usually, very frequently. These fine screens, they get clogged because they have very tiny openings. Okay, for that what happens, very frequently the fine screens, it is needed to be cleaned. Okay, which is not possible in an industry to, frequently you have to clean that fine screens. So therefore nowadays what happens, these core screens are used, and the work of the fine screens, it is generally, since it you removes the only the fine suspended solids, so the work of the fine screens, it is generally done in the next step, that is your sedimentation step. Okay, in the plain sedimentation step, the work of the fine screens is generally done in that step. Okay, again, okay, so I hope you have understood about the screen. Okay, so these are some. This is the plan of a screen. You can see this is the prospective view, and this is the section you can see of a bar type hand clean screen. Okay, so there is a movable screen also. Okay, movable screen is very good because you can like pull out this screen, and then you can clean, and you can again put it back in the this machine. Okay, so this is also a good movable type of screen, is nice. So these are the, you can see some of the pictures of your screens. Okay, so now next step is your plain sedimentation. Okay, so after you have removed or you have excluded the large size particles or the this with the help of screening, so now the fine suspended solids or the fine suspended solids remain. Yes, so these suspended impurities, okay, like which have a specific gravity greater than water. Okay, so these impurities, they remain in the water. Okay, so like the suspended impurities, they have a specific gravity greater than that of water, and they remain in that water. So these impurities, Therefore, they are what they now in the sedimentation process, what it is done, they are allowed to settle down under the action of gravity. Okay, they are allowed to settle down for, it is, you keep the water in still position for some hours, and what will happen, the suspended impurities, it will tend to settle down under the action of gravity. Okay, so next is, okay, so there are certain, one term is there that is known as your detention period. So the this detention period is what, like whatever, for the whatever time you are keeping the water in the still position or in the sedimentation tank. So that time period, it is known as your detention period. So it is written here that the basin in which the flow of the water is retarded is called the settling tank or the settling basin. Okay, settling tank or the sedimentation tank, or also it is known as your sedimentation basin or clarifier. And, and the theoretical average time for which the water is detained in the tank, okay, for which the water, when the water up to whatever time period the water is remaining in the tank, so that time period, it is known as your detention period. Clear? Okay. So next is your comes your theory of sedimentation. So there are three theories behind your sedimentation process. Okay. So there are three factors, actually, you can say. So when the settling process or the sedimentation process is happening, so when this process is comes to a rest, so there are certain factors which opposes this thing. Okay, so what are those? The number one is your the velocity of flow. So this velocity of flow which carries the particle horizontally. Obviously, the velocity of water, it will carry the particle in the horizontal direction. Yes. So the greater will be the flow area. So the lesser is the velocity. Okay. And hence, more easily the particle will settle down. Okay, so like when the velocity, the flow area will be more, so when the flow area increases, the velocity will be less, and hence what will happen as a result, the particle, it will settle down more easily. So next, number two is your the viscosity of water. Okay, the viscosity of water in which the particle is traveling. So the viscosity, it is, inversely proportional to the temperature. So like the warm water, it is less viscous, okay, and therefore it will offer less resistance to the settlement. Okay, so this viscosity, it is also a factor, it varies inversely with the temperature. Number three is your the size, shape, and specific gravity of the particle. So whatever the if the no the specific gravity is more, okay, the more readily the particle will settle down. Okay, so this size and shape of the particle, it will also affect the settling rate. Then comes this formula. Okay, this formula is known as your final Stokes equation. This is known as your final Stokes equation. And this formula, it is used only when your diameter of the particle, it is less than 0.1 millimeter. Okay, and also it is for a viscous flow and also for small sized particles. Okay, when your Reynolds number, it is less than 0.5, only then you will be using this equation, where here your G is what? G is your this small g, oh sorry, this Vs is your velocity of settlement. Okay, velocity of settlement. Then your d is your diameter of the particle in meter. Capital G is your specific gravity of the particle. Then your small g will be your acceleration due to gravity. Okay, Then nu is your kinematic viscosity of water. Okay, so all these things are given. If some numerical is given, you will be able to use this equation when your diameter of the particle, it will be less than 0.1 mm. Okay. After that comes your two more equations. Two more equations are there. One is your Newton's equation. Okay, Newton's equation is there. You can see this equation. This is a Newton's equation. So this equation, it is used, okay, when the settling particles, these are larger than your 1.0 mm. Okay, when it is, these equations are all about your settling velocity equations. Okay, settling velocity equations. So we have got the equation when the diameter is less than 0.1 mm. So now this equation, this Newton's equation, it is your like when the diameter will be greater than 1 mm. Okay, and also another one is there when this is known as your Hazen equation. This Hazen equation is when it is used when the particle, it is lies between your 0.1 mm and 1 mm. Okay, so if it is between 0.1 and 1, then you will be using the Hazen equation, and if it is greater than 1 mm, then you will be using the Newton's equation. So three equations you have got. One is Stokes equation, Newton's equation, and the other one is your Hazen equation. Okay, so now we will be doing one numerical. You see this question. It is says that find the settling velocity of a discrete particle, okay, in water under conditions when Reynolds number is less than 0.5. The diameter and specific gravity of the particle is 5 into 10 to the power minus 3 centimeter and 2.65 respectively. So water temperature is 20 degrees Celsius. Kinematic viscosity is given as your 1.01 into 10 to the power minus 2 centimeter square per second. So here it is told to find you. So whenever a numerical is given to you, first you always read the question nicely. Okay. Then you write down the given parts. What things are given. Okay. Then it is told to find you the settling velocity of a discrete particle. Okay, so now what things are given? Your Reynolds number, it is said to be having less than 0.5. Okay, then you can know that since it is less than 0.5, so you can be using the first Stokes equation. Yes, because there it is written in the equation, the condition is that here the Reynolds number is less than 0.5. So you will be using the Stokes equation. So you write down the Stokes equation. So it's written here, it is Stokes Z by 18 is in bracket, it is G minus 1 into D square by nu. Okay. So what is the capital G? It is given in the equation specific gravity. It is your 2.65. So 2.65 you have written. Then what is the small d? Small d is your 5 into 10 to the power minus 3 centimeter. So now you convert it to mm. Okay. Since like the condition was when d is less than 0.1 mm. So you have to check whether this 5 in this d which is given in the question, it is relatable, or it is like relatable to the given condition or not, because in the equation it is said that it will be d is equal to less than 0.1 mm. So that means you have to get the d, you have to check whether the d given in the question, it is less than 0.1 mm or not. Okay, then it is given as to be your 5 into 10 to the power minus 3 centimeters. So if you convert it to mm, it will come out to be 0.05 mm. So which is, you can see it is less than 0.1 mm. So it is completely okay. Okay, then what is the viscosity given to you? It is your 1.01 into 10 to the power minus 2 centimeter square per second. Okay, then small g, it might not be given in the question, but you should know this value. It is 981 centimeter square per second, and if it in terms of meter, then it will be 9.81 meter square per second. Okay, Now, after getting the values, you put the whole thing into your equation. Okay? In the settling velocity Stokes equation, you put it down and you the answer you will be getting out to be 0.22 centimeter per second. Okay, so this is your final answer. I hope this numerical is clear to all of you. The PDF I will share later. You can do it in your notebook. You can try this question in your copy. Okay. Okay, then today up to here only we will do. In the next class, I will be going to your sedimentation tank part. Okay, the next method we will be going in the next class. I hope today's class is clear to all of you. Okay, so let me take your roll number. Roll number. Can you people say serially the roll numbers?
Roll number 1.
Roll number 1. Okay. Next. 3. Okay. Then
4, ma'am.
4. Okay.
Row number 4.
Yeah, 4. Then next. Yeah, next. Come on, anyone? After 4.
12.
12. Okay. Then
Row number 8.
okay,
Ma'am.
8. Okay. Then
Ma'am, 14. Row number 101.
14. 14.
Yes, ma'am.
101. Okay, 101 it will come last. Okay, I have noted down. After 14.
Ma'am, 20.
20. Okay. Then
21.
21. Okay.
22.
22. Next.
26.
26. Next. Next. After 26. Any one of you?
Ma'am, 112.
112. Okay. Then
90.
90. Okay.
29, ma'am.
90. After that, what?
29.
29.
Thir-
Okay.
30, ma'am. 30.
30. Okay. 30. Then
93, ma'am.
93. Okay. Then
Ma'am, 76.
yes.
76.
76. Okay. Then
78. 109.
78. 78 is there?
Yes, ma'am.
Okay. 78.
55,
Then
ma'am.
after
Ma'am,
78,
54.
45.
Ma'am, 54.
Okay. 45. Then 54. Then
Ma'am, 84.
84. Okay. Then
Ma'am, 102.
102. Okay. Then
109.
Ma'am, 77.
77. Okay. Just now who told after before 77? 109. Okay. 109. Then anyone else?
92, ma'am.
92. Okay. 92. Okay. Then how many? Let me 1, 2, 3, 4, 25. But there are 26. One is not there. Okay. 88. Okay. 88. Okay, let me read it out. Okay, your roll numbers you check once. Roll number 1, 3, 4, 8, 12, 14, 20, 21, 22, 26, 29, 30, 45, 54, 76, 77, 78, 84, 88, 90, 92, 93, 101, 102, 109, 112. Did I miss anyone? I guess no. Okay. Okay, then let us conclude today's class. We will meet in the next class on Tuesday. Okay, thank you.